Hello, now we are going to start our syllabus, Unit 1, that is solution to algebraic, and Unit 1 first topic is solution to algebraic and transcendental equations. Solution to algebraic and transcendental equations. Now first thing comes in mind, how to define algebraic and transcendental equations. An equation of the form fx is equal to 0 is called algebraic or transcendental equation depending on whether fx is purely a polynomial of x or contains exponential, trigonometric, logarithmic functions. Not all, it can be possible that it might contain only exponential terms, or it might contain only trigonometric terms, or it might contain only logarithmic terms. But when these terms are present in an equation, it is called transcendental equation. If it is purely a polynomial of x in equation format, then it is algebraic equation. Clear? For example, you can see that 2x cube plus 3x square plus 17 equal to 0 is an algebraic equation, while 5x cube plus 4 log x plus 2 sin x is a transcendental equation. Now three methods are there. Suppose that three methods are there in your syllabus which you have to study. The bisection method, regular falsi method, which is also known as method of false position, and third is Newton's-Raphson method. Newton's-Raphson method is the most frequently asked question in your paper, and then comes bisection method, and after that comes regular falsi method. Three methods are in your syllabus: bisection, regular falsi, Newton's-Raphson method. Okay. Now we start with bisection method. Bisection method, this method is based on repeated application of intermediate value property. Let the function fx be continuous between a and b. The equation which you have been provided, we suppose it as fx. For definiteness, let fa be negative and fb positive. Then first approximation to the root is x1 is equal to half of a and b. We are bisecting it, therefore bisection method, half of a plus b. Then first approximation root. Now if fx1 is equal to 0, then x1 is the root of fx equal to 0. Otherwise the root lies between a and x1 or x1 and b accordingly, as fx1 is positive or negative. This point you have to remember very fast, that the root lies between a and x1 or x1 and b accordingly, as fx1 is positive or negative. It means that you have to only take 2 points, one positive, one negative. Then we bisect the interval as before and continue the process until the root is found to the desired accuracy. Observe that in this method we use only the end points of the interval, for which a fa into fan into fbn is less than 0 and not the values of fx at those end points, to obtain the next approximation to the root. Now in GATE and other competitive exams, they do not actually ask you to find the roots. They just ask how many number of iterations required to number of iterations for desired accuracy. The number of iterations, how many number of iterations are required. For that you have to use this formula b minus a, which is the interval in which they are asking you, and error is e is the error, epsilon, and 2 to the power n, where you have to find n only. N is the number of iterations required to get the epsilon permissible error. This method is also known as Bolzano method or interval halving method. Bisection method is first order convergent or linearly convergent. It means that by using bisection method, if a question you are solving, it will take more and more time to reach the root of desired accuracy. Is that clear? Now we are going to start the questions on bisection method in my next video lecture. Okay, thank you.